Hello there, and welcome to this short presentation on how social robots actually work. In this particular unit, we look inside the robot and explore the real technologies that allow it to sense the world, think about what is happening, act safely, and relate to people in meaningful ways. You do not need a technical background. Everything will be explained in everyday language.
And before we go on, just to remind ourselves, what is a social robot? A social robot is a machine designed specifically to interact with people. It does more than move or perform mechanical tasks like an industrial robot. It notices humans through its sensors. It makes simple decisions on its own, and it communicates through movement, gesture, and voice. Robots like the QT robot, Fur Hat, or the Japanese robot Lovot are examples of this. They are built to take part in social life, whether that's supporting children, assisting therapists, or offering companionship.
Thanks for that, Perry. Yeah, so to understand any social robot, it helps to break its behavior into 4 steps. First, the robot senses the world using cameras, microphones, and touch sensors. Next, it thinks. It runs software that interprets what it senses and decides what to do. Then it acts through motors, movement, speech, and expression. Finally, it relates. It times its responses, it adjusts its tone, and tries to create a comfortable human-robot interaction. This loop runs many times every second.
Robots notice the world using a combination of different sensors similar to human senses. They may use cameras that can see depth, or a LiDAR sensor, which is a small laser that measures distance. Microphone arrays allow the robot to hear not just sound, but the direction it's coming from. And touch sensors in the shell or the skin of the robot allow it to feel contact. A device called an IMU helps the robot to understand its own movement and balance. And all of these sensors taken together produce streams of information. The robot's software blends them together so it can build a picture of what's happening around it.
Yeah, so inside a robot is a small but powerful computer, which we might call its brain. It runs software that allows the robot to understand speech, recognize faces or gestures, and choose appropriate actions. Some of this processing happens directly inside the robot for privacy and safety reasons, but other functions, such as updating the robot's knowledge or downloading new abilities, can be done through secure GDPR-compliant cloud connections. Robots do not think like humans. They follow patterns, learn from data, but have no emotions or awareness.
And once a robot has decided what to do using this software, it uses its motors and joints to move safely. These joints have built-in flexibility, or what's called degrees of freedom, which helps protect people during close interaction. The robot can, if you like, speak using text-to-speech systems and can show expressions using lights, gaze direction, or projected faces. Again, a behavior manager coordinates movement, voice, and expression so that the robot feels coherent. It can turn towards you when you speak, nod in response, or change its tone of voice.
Thank you, Perry. And as we have seen earlier from our Lovett case study, it is obviously a leading example of a social robot designed for companionship. Now, the Lovett robot contains more than 40 sensors and 50 actuators, allowing it to feel touch, react warmly to people, and move in expressive ways. Lovett uses what engineers call an emotion engine. This does not mean that the robot has emotions. Instead, it adjusts its behavior in ways that resemble attachment. For example, it seeks attention when it's ignored. It can act in a calming way when held. Importantly, Lovett processes data on the device itself. It does not stream video or audio to the internet or the cloud. This protects user privacy.
Now, safety is absolutely essential in environments such as schools, hospitals, and homes. And international standards guide how service robots must be designed and tested. To make them safer in use, robots often display transparency cues. These are lights or messages that tell you when the robot is listening, for example, when it's unsure, or when it might need help. The standards also include speed limits, torque limits, or how strong the robot is, and emergency stops to ensure safe operation around people. And at all times, humans remain in control.
Now, as we've been exploring throughout the MOOC, social robots are now being used in a variety of settings. They're being used to support children on the autism spectrum, to help with rehabilitation exercises, to offer companionship, and in schools to guide or motivate learning activities. Robots like QT, Pepper, and Lovett show how this technology can be adapted for frontline services. Crucially, robots must be co-designed with practitioners and service users so the technology aligns with real needs and values.
So, what's next? As we think about the future, robots are shifting from being simple machines to becoming relational partners, tools that can support communication, independence, and well-being. A useful reflective question for you is, how might you design a robot for your own practice or home or setting? What would it need to do, and what values would guide its behavior?